Hello everyone, so today we're going to talk about oxidation reduction reactions. So this is new to you all. We did not talk about this in Chem 1. So your topic today is ox/red or oxidation reduction. You just don't have to type the whole thing out. Your goal is I can explain and label the different parts of oxidation reduction reaction. So oxidation reduction or redox, that's another form or way you can say it. Those reactions involve the transfer of electrons from one substance to another. Oxidation reduction reactions provide us with energy from food. They provide electrical energy in batteries, and then it also occurs when iron rusts. So these are reactions we see a lot that are very necessary in real life. So an oxidation reduction reaction transfers electrons from one reactant to the other. It loses electrons in oxidation. One way you can remember that is loss of electrons, or oxidation is loss. It means you're losing your electrons. It's becoming more positive because you're losing your electrons. It gains electrons in reduction, or gain of electrons, or I know it as reduction is gain. So just to reiterate that, oxidation, you lose electrons, like oil rig. Oxidation is loss. Reduction is gain. How to ID the atom being oxidized and the atom being reduced. So I'm just going to kind of warn you, there's going to be a lot of words. You're not going to really know what I'm talking about until you type it all out, and then I do examples with you following through these steps. So it's okay if you don't understand it when you're typing this stuff down. Hopefully, whenever we do practice together in this video, you'll understand where it's coming from and what it's talking about at that point. So you put ionic or oxidation charge for each element. If it is one type of element, then the charge is 0. So if there's only one element it's talking about, the charge is going to be 0. Everything else, you look at the periodic table, just like we did last unit, and you write the ionic charge for it. The one gaining electrons or becoming more negative is the atom being reduced. The one losing electrons or becoming more positive is the atom being oxidized. So how do you ID the reducing agent and the oxidizing agent? So we know at this point what's being reduced. We know what's being oxidized, but what's the agent that's causing it to happen? So you find the atoms being oxidized and reduced. Looked at the reactants. The compound with the atom being reduced is the oxidizing agent. The compound with the atom being oxidized is the reducing agent. So what's being oxidized and what's being reduced, what we talked about in the last slide, is just one single element. The oxidizing agent and the reducing agent is the actual compound in which it is located in. So how to write the half reaction? For oxidation, write the atom being oxidized with charge. The electron it is losing, yielding the element on the product side with a new charge. For reduction, write the atom being reduced with the charge, plus the electrons it's gaining, yielding the element on the product side with new charge. Now just remember, yielding, when I say yielding, that's the arrow. So that's where you'll draw that arrow. So I'm going to do this example on a piece of paper and show you what the heck I was talking about in the last couple of slides, and how we find what's being oxidized, what's being reduced, the oxidizing agent, the reduction agent, and how to write both half-lives. All right, so now I'm going to go over practice for oxidation reduction reactions and how we find this information based off this reaction. So again, oxidation is where you lose electrons. Well, if you lose electrons, that means it's going to become more positive. Reduction is where you gain electrons, so that means it'll become more negative. So the first step that you do for this is you write the charge above each element. Now, if it is just one single element, the charge will be 0. So here we just have Fe. So since it's just one element, we will put a 0. Now V, if you look at the periodic table, it's a transition metal, so I will give you that charge. It is +3. O, if you look at this periodic table, O has a -2 charge. Fe here is also a transition metal, so I would have told you that's +3. O is a -2 charge. V is a transition metal, so I tell you it's +2 right here, and oxygen is a -2 charge. All right, so the one that is gaining electrons, or that becomes more negative as you go from one side to the other, is your atom that's being reduced. The one that's becoming more positive or is losing electrons is the one being oxidized. So here, Fe is 0. Over here, Fe is +3. So it's what's become more positive. And since it's becoming more positive, that means it's lost electrons, which is your oxidation. So your atom oxidized is Fe. Okay. The atom being reduced is the one that gains electrons or gets more negative. So right here, V is +3. Over here, V is +2. Well, since that 2 is less than 3, then that means it's losing electrons. So that would be a V is your atom being reduced. So now we're going to look at how we find the oxidizing agent and the reducing agent. So to find the oxidizing agent, you actually have to look at the atom being reduced. So it's kind of like opposites. So the atom being reduced is V. To find the oxidizing agent, you find the compound that V is in on the reactant side, so this first half. So your oxidizing agent would be V2O3. For the reducing agent, you find what's being oxidized and you write the compound it's in. Well, in this case, it's just Fe. So Fe is all you would put for that. So now I'm going to go over how we write the half reaction for the oxidation and the half reaction for reduction. So for oxidation, you look at the atom being oxidized. Here it's Fe. You find Fe in the reactant and you write it down and you put the charge it has. Well, in this case, it has 0. So we could just put Fe. Now, since it's being oxidized, it's losing electrons, so we put a minus sign. Then we have to put exactly how many electrons it lost. So over here, it has 0. Over here, it's a +3. So that means it lost 3 electrons. So to show that, you would do minus however many electrons you lost, so in this case 3. And then you would put the symbol for electron, which is E with the minus sign. Then you put your yield or your arrow, and you find where Fe is at over here. So Fe, and it has a +3 charge. So that's all you have to do for the half reaction for oxidation. So now let's look at the half reaction for reduction. So our atom being reduced is V. We look over here, we have V with a +3 charge. Okay, it's going to be plus, and we'll see how many electrons were gained. So here we have a +3. Here we have +2. So that means it only gained 1 electron. And that gave us a V with a +2 charge. That's all you have to show for that half reaction. So once you get that complete, if you go to slide 12, here is your oxidation reduction reaction practice problems. You have your equation, and then you'll need to fill excuse me, you'll have to fill in each of those blanks for that answer. If you have any questions about this, let me know. I'll be happy to help.